Today we will talk about embryology. And I just want to say that this is not an embryology course. I'm going to give you a 1-minute little lecture on embryology, which we will touch upon as we go through the body system. We'll kind of come back and revisit a few elements that I'll be showing to you about body development. And the reason that this is important is because what I want you to get out of this is the origination of our tissues, kind of why we have the body plan that we have, how this all came about. And as you, especially when we get into the internal organs, there's a lot of folding. And in order to, and our brain as well, and in order to understand this sort of folding process, it's important to kind of understand how it all began. And so we'll be touching on this from time to time. But I do want to tell you, if you like embryology, San Francisco State Biology Department has some really excellent classes on embryology. And if you are interested in this, we have some very, very good classes in it, and several researchers that do research with embryos of not human embryos, but embryos and embryonic development of the different animals. And so, I feel, and as an anatomist, I know enough about embryology to kind of understand it, but please don't expect a whole course in embryology. It's just today. And then I want to tell you that online on iLearn, in the segment for histology, there is a copy of this page, which are embryology of tissues, terms and notes. And I would suggest you download this and study it. This will at least give you some of the terminology and some of the sort of oogenesis and morphogenesis that we're going to talk about today. It'll give you kind of a good kind of cliff notes on what we're going to see today. And so I want to make sure you study that. So the first thing we're going to do is I really love looking on YouTube. I suppose probably a lot of you do too. We never had YouTube when I was in school. It was the professor dryly lecturing, we're falling asleep, taking our notes, and PowerPoint can have that same effect. But what I love to do, and you'll get a lot of this semester, is I don't do it all the time, but when I have time, I like to surf the YouTube, and I have found some of the most amazing videos. And when I find those, I'll bring them in for you to see. And usually they're very short. And so I have one for you today that is by this is one I actually had to purchase. And it's a company called Mind Bites. I don't know if you've ever heard of it. But anyway, they're very inexpensive science short snippets on different topics in science. They're very excellent. And so I'm not going to click on it because as soon as I click to the next slide, we'll start seeing him. But I'm going to tell you about this man that we're going to hear. And I love the way that he explains cleavage, the blastocele formation, and sort of this early development stage, which is crucial to understand, this early developmental stage, to understand how our organs have been folded into the body, and how the morphogenesis and oogenesis, how the origin of our organs, the origin of our bodies, how this has come about. So this is a man by the name of George Wolfe, and you'll see when I open it up, you'll see he's very, very wonderful. And he teaches at Cornell and a lot of other places, and he's just a Discovery Channel. You've probably seen him on TV before. He's just wonderful. That, and we can watch it more than once. So there are a couple, he'll give you quite a few vocabulary words. These are important words, so we would write those down. And we can watch, it's a short video, so we can watch it twice if you want. Sometimes it's helpful to watch something like this a couple of times. So here we go. And then we'll talk a little bit about
that. What happens next? Well, now comes events that books have been writing about. We'll condense it down just a little bit.
Can you all hear
We're going
it?
to talk about the first thing that begins to happen, and that is a series of mitotic divisions called cleavage. Cleavage is a very rapid series of mitotic divisions. The cells absolutely fly past G1, go into S and G2. In other words, what happens is you don't get cell growth during cleavage. The cells start out as one egg cell, split into 2, split into 4, split into 8, split into 16, and rapidly move into a ball of cells. So it ends up something like this. Cleavage, therefore, starts out as one cell. We're going to get 2 cells. 2 will give 4, 4 will give 8, and you'll notice that the cells are getting smaller at each division. And so what's going to eventually happen is you're going to look something like this. You take a look at this, here's the first cleavage. Now one of the things I want you to understand is we're going to be talking later about cleavage plates, and that's what's meant right there. So there's the 1 cell that just became 2. And then 2 cells will become 4. And again, these are elongated, and you see the cleavage plates right there. Well, eventually, you start to get this ball-shaped looking thing. And that is the very first stage beyond the zygote that we can put a name on, and that's called the morula, which is a solid ball of cells, okay? And eventually, this solid ball of cells, because of the division patterns that are going to occur in there, and the pressure is put on by the cells pushing against each other, is eventually going to form into a hollow ball of cells. Which is going to be called the blastula. Now, let's take a look at a diagrammatic representation of what's going on here. In our first series of divisions, okay, 1, and you can see what's happening, and now let's take a look at what it looks like inside of there, because inside of the blastula, it's hollow. In fact, there's a structure in there called the blastocele. Cele means cavity. And we're going to see in a minute what this is all about, but I want to concentrate on this for a second. Does this happen in all developing embryos? Absolutely. Does it happen the same way? No. And that's where you get into the reams of information that have been produced in looking at the way different organisms develop. For example, if you have an organism that's going to have a lot of yolk, okay, you're going to get, and yolk starts out as just, it's an egg, it's cytoplasm, okay? But then you get, what ends up happening is after your first division, the yolk gets concentrated in one of those 2 cells, and then those cells, because they have a lot of yolk mass in them, will divide a little bit slower, and so they'll end up as bigger cells than the cells that are going to end up turning into the creature itself. So some cells, like say a frog's egg, will end up with literally a polarity to the egg, with an animal pole, which will give you the animal, and the vegetal pole, which stores all of the yolk. So this is and you know, some don't cleave all the way through. And so you get something like the chicken egg that has these special kinds of cleavages and that don't go all the way through. Like I said, there have been reams of information written about this, but let's understand the process. That's where we're always right there. Let's understand the process. And so now we have this thing called a blastocele. And now we have to start thinking about, okay, now that we have all of these cells, how are we going to generate organs from them? It's just a ball of cells. And so now we come to a process called organogenesis and morphogenesis, okay? In other words, the formation of organs and changes, morphogenesis. And boy, hang on for this. This is great stuff. Well, as we take a look at, say, something like a blastocele and a blastula, I want to take a look at this top picture right here. Okay, now this is a cell very much, actually what this one is this is a frog, okay? So you've got a large yolk mass, okay, down at the bottom, and this is going to be a fairly complex one. But the bottom line is you still have a blastocele right here. We've mapped this in what we call the fates, and in other words, the different colors are going to represent the different layers of what they're gonna turn out to be. Remember, we're gonna be talking about a triploblastic embryo here. Now, that's a complex one. Let me show you one that might be just a little bit simpler, and we'll use that as our model. Let me show you how, for example, a sea urchin might develop. In a sea urchin blastula, which would look something like that, the first thing that's gonna happen is you're gonna develop a pore right here called a blastopore. Right? Well, guess what? Blastopore. You and I, and frogs, and chickens, same kind of thing. We're gonna develop a blastopore. I'll show you that on that situation later. And what happens in the blastopore is you start to get what is called, now this is where it gets very cool because the cells start to interact with each other. Some of them elongate, they start to move along each other because of cell surface interactions, because of cytoskeleton changes. There's a whole complex series of reactions that cause these cells at the blastopore to start to get longer and literally to start what is called an invagination, okay? And so what we're gonna get is we're gonna get literally a sucking in, if you will, of the blastopore. And in addition, you're going to get some cells migrating in there. So let's draw this. I'll try to make this a sequence. So here's my blastopore, my opening to the blastocele. And we're gonna start getting some cells moving in there. So I'm gonna draw these cells in here as having moved in there. I'm gonna draw them in red because they are going to end up as, just so you know where we're going, these are gonna end up as mesoderm, the middle layer. Now, I said that it starts to do an invagination. By the way, the movement of these cells in there is called involution, mesoderm. So these cells moving in there is involution, the movement of the cells. And so we have, number one, we have movement of cells, and two, we have invagination, which means that we are literally getting a depression in there. And so let's draw that. And so in the sea urchin, what's going to happen is it starts to bend inward, literally. Okay? And so we're pulling this. We're going to cellularly, literally, there's going to be, fibers that are going to pull this in that direction. Now, watch what's going to happen next. As we continue to build up our mesoderm, as cells continue to go in here, this is going to continue in this direction. And watch what's going to happen next. Eventually, you're going to get something that's going to look like this. Get it? And look, you have an opening here and the potential for an opening right there. You see? Because look, that used to be the top of this egg. Isn't that cool? And so it's or the top of this embryo. And remember our mesoderm in here. Now look, you guys, what did we just form? We just formed our third layer of cells. Because if you think about it, here's my ectoderm, here's my mesoderm, and here is my endoderm, my inner layer. And eventually we get something that's going to form an opening there with what can become a digestive tube. You see? And you can have the mouth here and the anus there. So you have the digestive tube, you've put in your mesoderm, because this is all cells, let's not forget that. When I pull these in, I'm talking cells, I'm not talking single cell. So all of this is cells, cells, cells. Those are endodermal cells. And all of this out here will be ectodermal cells. How cool is that? This is so great. Well, guess what? It's no more, it just looks harder in the frog egg. In the frog egg, we're gonna get a blastopore forming too. And we're gonna get migration of cells, and we're gonna get invagination, and that's gonna happen right here. There, you can see that a little bit better. Right in there is where we're going to start our invagination and our involution. And as cells, and look what's happening. Now, here's the blastocele, right? Look what's happening to the blastocele. As the cells move in this direction, okay, and they start to move into the blastopore, what's starting to happen is you're getting layering of cells. So you're getting layering of cells in here, where I'm coloring, and that's going to be your ectoderm. blastocele, I'll just put C-O-E-L, disappear. It's closing up as more cells build in there, and you're literally making a brand new cavity. And that brand new cavity is going to be called the archenteron. Lots of vocabulary here, but that's okay, we're going to refer to it as something. And so what we've done is, once again, we have formed a situation where we have an opening here, and the potential for an opening over here at the other end of the archenteron, and this diagram doesn't show it. So once again, we now have formed, what have we formed? 3 cell layers. We have the outside cell layer, the ectoderm. We have the middle cell layer, the mesoderm. And we have this layer here lining the archenteron, the endoderm. So how does that turn into an embryo? And you? Well, you know what? The rest of it is just sheer old logic. What do you think? Well, how do cells differentiate? 300 books written on that. But in general, what's going to happen next? The 3 layers are going to differentiate. And if you think about it, all you need to do is realize, if you understand what ectoderm means, you're going to know what the ectoderm turns into. It's going to turn into the skin, isn't it? Because it's on the outside. It's going to turn into the nerves in the skin, okay? It's going to turn into your nervous system and the outsides of your eyes. So your nervous system and your cornea and your lenses. Anything literally that's toward the outside of your body is going to be ectodermal in origin. On the other hand, mesodermal stuff is going to be the stuff in the middle, okay? Meso-middle. And so one of the things that happens is it forms something called the notochord, which we'll talk, it's literally a cartilaginous rod that causes the embryo to stretch. More on that at another time. It's going to form the notochord. The notochord actually ends up forming part of, for many organisms, ends up becoming the basis for the vertebrae. It's going to form your muscles. It's going to form your skeleton. It's going to form all those things that are unique to something with guts. Okay, it's going to form the circulatory system, the organs, the reproductive system. Well, what about the endoderm? The endoderm's the innermost thing. So it's going to form the inner linings. The inner linings of many of these organs, like the digestive tract. I showed you how it forms the inner lining of the digestive tract right there. Okay, so it's going to form inner linings. You know, it's a brief overview, but the bottom line is this. We've gone from 1 cell to 2 cells, to 4 cells, to thousands of cells, and have begun to form an organism.
Okay, so did you like that? I think it's very clear in terms of, I mean, because I think this can be very complicated to understand, I mean, how this all works, and I can't really tell you physiologically why. I mean, like he said, I mean, you have to read a stack of books like this, and I'm not an embryologist, and I don't even want to pretend to be one. But, you know, just to know that this is how our bodies form, and it's pretty fascinating. Now, humans, we have a few different types of stages. So we're going to talk here just about, this is these words that he kind of used here. So this cleavage. And, you know, he said, if you remember from basic biology about the cell division, so it kind of, this whole process kind of speeds by that cell growth areas, which is why these cells can divide, but the beginning embryo doesn't ever get any larger, because we just cells keep dividing, and it's I can't tell you physiologically why, except that's what happens. And so you can see here that we have formed the morula and the blastocyst, and then we have the embryoblast and the blastocyst cavity. So you can, now he was giving you the very simple example of a sea urchin. Of course, humans are a little more complex, and he showed you a frog, which was more complex, but humans are a little bit more complex than that, but not much more, because frogs are vertebrates like us. And so now, to me, what is kind of interesting is that for us, our mesoderm, the ectoderm and endoderm form first, and I don't know if that was very clear, and then the mesoderm forms later. And so this is kind of, for humans, because we have this placenta and the embryo implants into the uterus and then forms this placenta, and we have this amniotic sac that develops. And so it's a little bit different process in terms of we have a bilayered embryo and then it develops into that third